Okay, thank you. So we will start where we left in the morning. So yes, so we discussed about like the elasticity of the demand earlier, and now we will apply the same concept and quickly complete the same concept for the supply as well. So like again the same things we are going to discuss for the supplier. So how the law of diminishing marginal product works for supplier is basically, if you see, yes, so there are multiple factors of production in a factory or in any power any production industry. So if you increase those factors, the quantity will increase very rapidly initially, but after a certain time, even if you increase a lot of production factors, let's say like fuel supply, after a certain time, even if you like put lot of fuel, the production will be limited and the quantity will basically uh, so if you see, the quantity will basically saturate after a certain time. So after factor production, the quantity will saturate, and the same can be like, with the increasing number of quantity, the factor of production will be increasing, and same in fashion, the price will also increase. So as more and more you want to produce, the mm, the amount needed to produce that will be very high. So just like the opposite of the marginal consumption, like if you want to consume more, you are willing to pay less. But if you want to produce more, you have to invest more for the next incremental production. Okay, so this is how. So this is the supply curve for the demand. And if we talk about the market equilibrium, so this is, let's say, supply curve, and the pi is the market price. So the Q quantity a supplier will produce, and the pi will be the price. So the area between the price and the supplier curve basically is the net supplier surplus. So if we talk about the overall market equilibrium from supplier and demand, so if we draw both supply curve and demand curve, so you can see this is the supply curve, the increasing basically a slope, and then we have a demand curve, the decreasing slope. So okay, if you push, can you open the chat? I think some issues are there, it will be visible. Okay, fine. So just keep it open. So the intersection of the supply curve and demand curve decides the market clearing, as we discussed earlier in the morning with that ladder curve. So we like arrange the supplier bids and demand bids in increasing order and decreasing order of the price respectively, and the intersection gave us the market clearing price, which is like here I have mentioned with the pi star, and the market clearing quantity is as a Q star. So how the equilibrium works basically, so let's say the prices has been reduced to pi 1. In that case, supplier will only produce S1, because as per his supply curve, otherwise it will be very expensive to produce more than S1, and he is only getting price pi 1. But as prices are being reduced, the demand will consume more basically, because prices are cheaper and it will try to consume more. So the supply and demand mismatch will occur, and in that case, when demand is more, supply is less, uh, the supplier will basically start basically what he will do is start producing more at a higher price. And similarly, as the demand is more, the demand and the supply is not there, deficit, so they will start consuming less, and they will again come back to this particular point, and that's why it is called equilibrium point. And same vice versa will happen if we increase the prices to a higher value. So that mismatch will be there, and both supply and demand will again move back or fall back on these curves, and basically attain an equilibrium point at the intersection of these two. Okay, so Next is, let's say I have drawn a supply curve and demand curve. Okay, and this time, instead of like parabolic, straight lines has been used. So if you see here, the intersection point is the pi star, that is market clearing price here. Okay, and the q star is the market clearing quantity, and x axis we have quantity, on y axis we have basically prices. Okay, so if you see here, the two triangles you can see in different colors like blue and this uh, yellowish color. So these two triangles are basically, so upper triangle is basically the demand surplus, okay, and lower triangle is basically your supply surplus. So this is your demand surplus, and then this is your supply surplus. Okay, and the summation of both supply surplus and demand surplus is equals to global welfare. Okay, and if anyone has some doubts here. So it means you are not looking at the slides what I have mentioned, right? So my students are there; they are smiling because they know that these kind of tricks I usually do. So you can see here, I have mentioned demand curve on this axis and supply curve on this axis. So you should have noticed this one, that the increasing slope is supply curve and the decreasing slope is demand curve. So I purposefully basically placed demand curve here just to check how much attention you are giving. So okay, so next is, let's say due to some reason, some artificially high price is set up. So let's say the price is here, and a price of basically, so if I comment it, let's say the okay, so some price is being set up here, and if you see this particular price, like a higher price instead of the price star, the demand surplus is very less and supply surplus has been increased. Okay, so the demand surplus is being reduced as compared to the earlier case, and supply surplus is basically this part. And if you see, this white portion is no longer a surplus, either supply or demand surplus. So with the artificially high price, um, a larger supplier profit, so supplier profit will increase. Smaller consumer surplus, so consumer surplus will, demand surplus will reduce, and overall social welfare, which is basically this outer triangle, which comprise of both, will be lesser. Same can basically go with the artificially low price. So let's say if we have set up a price here as a low price, this is the price, let's say lower price. In this case, the supplier surplus is being basically reduced. Okay, so the supplier surplus is reduced here, and demand surplus or consumer surplus is increased, but still the overall social welfare is smaller as compared to the very first case. So the global welfare or social welfare is basically this part where we have set artificially high price or low price, and this small triangle in green color is basically called deadweight loss. So this is, you can say, loss in the welfare, and it is for both supply and demand. And this is because of, like, due to some constraints, the quantity cleared can be less, or as we are talking about like cross subsidization, we are setting very low price. So it's a free, like earlier discussion, we were talking about the free electricity. So basically we are setting the price is very low. Free can be like very low price. In that case, the overall societal benefit at the global welfare, at the social welfare will reduce. Okay, so that is not really, your, am I audible yet? Yes, looks like okay. And now I think I'm audible. Yes. So there was some network issue. So the deadweight loss is basically caused by the price distortion, and usually the price distortion are due to the government intervention. So government can set low price and high price, as we discussed earlier. So tariff setting rather than competitive pricing. So if we set the prices based upon certain tariff instead of some competitive pricing, uh, like we are talking about like MRP, right? The earlier there was a doubt about MRP. Like, why can't we set a maximum retail price? So the competitive price is basically depends upon the supply and demand balance. Like if demand is more, the prices will go high. Demand is less, prices will go low as well. So those prices are the outcome of the market clearing. But if we set a fixed price, then there is no competition and there is no market clearing or market price formulation. I think I have some network issues connected. Am I connected again? Okay. So yes, I am again connected and disconnected. So do you have any idea like what can be the technical regions? Again, my okay. Wait. Push. Do one thing. Uh, I will turn off my video because maybe because of this I am getting disconnected continuously. Yes. So there is a question: who will stop the big generators? Am I audible now, right? So who will stop the big generators and discounts from the distorting the price? Yes, it's a very. I have that also in my PPT, and in the last slide we will talk about it. Not audible yet? फोन वाले से और भी स्लो होगा. Should I disconnect and connect again? इनमें 90 वाले से फास्ट है. कुछ आईक्यू करके आएगा. Am I connected again? Kush, am I audible? It's audible, and but I think I am out of the webinar. Why can't I? Okay, yes. So, yes, what can be the technical regions? Anybody? So, technical regions is we discussed earlier the transmission lines. So let's say a certain quantity has been cleared, okay, and because let's say due to some नहीं मैं कनेक्टेड हूँ. uh, am I audible now? Push. Okay. So what can be the technical reasons like so the technical regions we were discussing, so the technical regions are, let's say, at certain transmission line, there are, let's say, two circuits, and one of the circuit is out. So instead of, let's say, like 100 megawatt, we are only able to schedule 50 megawatt. In that case, the quantity which was supposed to be cleared, let's say 100 megawatt, but because of the less transmission corridor, we are only able to supply 50 megawatt. So those can be the technical regions, like transmission congestion is one of the technical regions to basically for the deadweight loss. Now there was a question: who will stop the big generators and discoms from distorting the price? So yes, to go into that, first of all, we have to understand what is the nature of our electricity market. So there is called one thing is called perfectly competitive market, and there are some certain attributes of a perfectly competitive market. One is a large number of small players should be there. So there should not be big players. That is one attribute of the perfectly competitive market. But again, we have big generators in our system. So because of that, we cannot call it perfectly competitive market. Okay. The second point is the complete information. So the consumer and sellers should know the price set by all the firms. Okay. Then third point is free entry. So there is no barrier uh, for entry into and exit out of the market. So if somebody wants an exit from the market, he can do that. And if somebody wants to in the market, nobody should restrict that as well. Now the question is, in perfectly competitive market, the firm, whether it is a buyer, any buyer, or whether it is seller, uh, so there are two types. One is price takers, one is price makers. So in perfectly competitive market, everybody will be price takers. So nobody has, like the big generators we are talking about, they can distort the price and they can be price makers. But in perfectly competitive market, we are assuming that all the players are very small, so large number of players are there and they are small players, so everybody is price taker, and the price will be the byproduct or outcome of the market. Okay. So if everyone is price taker, then the firm's supply decision under perfect competition will be very simple, irrespective of the demand, what demand is doing, or any firm basically whatever others are doing, it will be simply maximization of the revenue. So if you see the equation here, the pi is market clearing price here, y is the quantity, so price into quantity is the revenue minus cost. So this represents the cost function, quantity y. So here this is revenue minus cost, so it is profit. So maximization of profit will be the decision of a perfect by any firm in under the perfectly competitive market. Now what is imperfect competition? Okay, so in imperfect competition, firms decide upon the quantity produced so as to have direct effect on the market price. So obviously the quantities are being produced by the firms, and if they can manipulate that quantity, they can basically have effect on the market price. So there are two ways of doing manipulation of the market price. One is withholding the quantity. So like we can stock usually, like, general commodity market, sometimes people stock the goods. The same thing can be basically like replicated by withholding the quantities. So like they are able to produce more, but they are not producing the enough quantity. And second is raising the asking price. So whatever the asking price, they can increase the asking price. So we have seen that supply curve. So if they increase the asking price, the asking price will go very high, and it may basically increase the or manipulate the prices. So there are different forms of imperfect competition. So these are some terminologies from economics. One is monopoly. Monopoly is only one seller. So earlier we talked about, like, in traditional powers system, we had vertically integrated utility. Okay, am I audible again? Sure. Push. But I am connected. Okay. So monopoly is only one seller. So earlier the vertically integrated utility is the only one company. So we can say that is monopoly. Then we have oligopoly. Oligopoly is like finite number of sellers. So instead of a very large number of sellers, we have certain like finite number of sellers. Then it is called oligopoly. Then so these monopoly and oligopoly is from the seller point of view. Then we have the same terminologies from the buyer point of view. One is monopsony. So this is only one buyer. And then we have oligopsony, which is a small number of buyers. Okay. So next is, what is the difference between these two? Okay. So then we have the firm is price taker. It cannot decide the price. In monopoly, obviously it's a single firm, so it can make any price the firm wants. And then it faces a horizontal demand curve, and usually monopoly faces a market, a downward sloping demand curve. Okay. Then if we talk about the electricity markets we have, so monopoly is one single seller. Perfect competition is infinite number of or very large number of small sellers. So energy markets are in between. Okay. So all the energy markets are basically oligopoly markets. And there are multiple models in the economics to model oligopoly behavior, and it is also called imperfect competition. So there are like Carnot model, Stackelberg model, Bertrand model, and we will discuss the Carnot model here. So I will just quickly go through some mathematics, and then I will answer the, like, who will stop the big generators and discounts from distorting the price. So let's say there are n number of finite number of quantities are being produced. So we don't have monopoly, so it's not single firm, but we don't have infinite number of basically suppliers. So y is the, let's say, quantity being produced. So capital Y is the total quantity being produced. So there are n number of basically sellers which are producing this particular quantity. Now the market price pi will be the outcome of the market at the total demand being asked. So if total demand is too much high, the prices will also be high. And if demand is less as compared to, so this y is basically supply. So if supply is too much high, the prices will be low. If supply is less as compared to the demand, then the prices will be more. So this pi is the market price. It is the product of market. why is a single firm's decision, like what a single firm, ayat firm, should produce? So this is basically revenue minus cost of ayat firm. So like to optimize, we have to do first order derivative and equate equals to 0. So that is the like simple optimization technique. So if we derivate it and equals to 0, we will get prices plus quantity into derivative of the price minus derivative of the cost. Okay, and then if you rearrange everything, it's like, the cost can be shifted, incremental cost at this derivative of the cost can be shifted other side. And if you multiply y up y, and basically uh, pi y can be taken out, and this entire term can be rearranged by multiplying capital Y and capital Y. And here we can basically assume that, let's say, yi upon capital Y, which is this first term. This first term is basically the share S. Okay, so let's assume this is the, this first term is the market share of the firm. So let's say there are 10 suppliers, each are producing let's say 10 megawatts. So the total demand, total production is 100 megawatt, and the market share will be 10 by 100. So it is like 10 by 100, so market share will be 10%. But if we have large number of players, okay, and the second term here, this term is basically, the second term is basically elasticity of the demand. So this is basically how the demand is behaving with respect to price. So usually the elasticity, we can give it by elasticity. E is the elasticity function. So pi is the market price, and this is the incremental cost of an individual generator. If SI is very small, so let's say we are talking about a perfectly competitive market. In perfectly competitive market, we have assumed that there will be very large number of players. So if there is very large number of players, this n will go up to infinity, and in that case, the capital Y will be very much large as compared to the individual Y. Y1, Y2 are for those individual values. The total Y, the total supply will be very much high. So in that case, we can assume that this SI will be very much less or negligible. So if this SI is negligible or close to 0, this entire term will become 0, and the market price will be equal to the incremental cost of the generator. Okay, but if the share is different, so if this share is, let's say they have certain share in the market, then this product will be 1 minus something, so it will be less than 1, and the prices will be, this will go in denominator on the other side, and prices will be higher than the incremental cost of any producer. So this share decides the market power. So the big generators and discoms, yes, if their share is very much high, they can distort the price, and you can refer this particular equation by which they can distort the price here. Okay, so this particular equation, they can distort the market price. Now who will stop? So the regulator, the role or the job of regulator is to check for abuse of market power. If so, yes, in electricity markets there are very big power plants who are producing a very large chunk of power, so their share is significant and they have ability to affect the market price. But having market power is okay, but using or basically exercising market power is something else. So if somebody exercise the market power, the regulators are there and it's their job to check for abuse of market power, and they will stop the big generators and discoms from distorting the market price. Okay, so if you have any doubts in market, like how the market works, market clearing, different prices, social welfare, consumer surplus, demand surplus, uh, please ask. And then we will start on the, like, the hands-on on the games software. You can raise your hand as well, so you can ask the questions verbally. Is a centralized economic dispatch give the same incremental cost for all generators better for unbiased pricing? Yes, Satyanarayanan, we will discuss economic load dispatch. I think it's tomorrow we will discuss. But to give the answer to your question, yes, economic load dispatch and the market clearing are basically analogous. You can say that, and we will set up the definitions that like how the market clearing price can be obtained from economic dispatch as well. So yes, we will do that. And economic dispatch, yes, it provides the same incremental cost for all the generators, provided there is no limit is being hit. And if there is no limit of a generator is being hit, then the incremental cost, which is same for all the generators, is can also be used as a market clearing price, and that will be unbiased. True. So there is no question, so I will move to the next slide. Or so one question is, have you installed game software? So I would today it's okay. Today we are going to solve or see how we can use it, and very fundamental of it, not a big uh, piece of code. But I would recommend you install at least like the demo version of the code. And how to make it full screen. Okay, so I will share my entire screen. I can share. How? Screen one. Yes. So I will share my entire screen with you. Is it visible? Okay. So now if I see, let's say you can download games. So just simply type GAMS. Okay. And if you search, there will be a download button here. So you can go there, and then different the latest release is available, which is recently January 14 2026. And a demo version you can download, like for different operating system we have different downloads. So I have downloaded it, and by simply clicking on the like, so some this file will be downloaded .exe file. And by this just simply open it and click next, next, next. You will be able to install it, and this is how it will open the game studio where we are going to work. So this is the game studio, and here you can file, and you can open a new file which I have already opened here. So this is our new file. Now let me go back to the slide. Okay. There is a question. With PPS between power station and discom vastly, how do we model the social welfare? What will be its mathematical modeling? Will oligopoly concept used in real time by the ISO for solving the economic dispatch? So, Lokesh, PPAs are basically it's basically between a seller and buyer. So nobody obviously, if we are bargaining, if you go to any market basically, and we try to strike a deal, nobody is wants to be in loss. Okay, so PPAs are basically they it depends who has more bargaining power, and who is in need. So PPAs are bilateral. So those, whatever is the outcome of that PPA, the negotiation price, that is called like bargaining theory is being used to decide like model that one mathematically. And in that case, deadweight loss is basically outcome of market, not bilateral negotiation or bilateral contracts. So if there is a market, large number of sellers and buyers come together, and if the all of them come up, or basically the outcome is price outcome is from the market, then only we go for the deadweight loss, that okay, there is some loss in the supplier surplus and buyer surplus. But yes, for PPS it's mutually decided, so we cannot call it loss in some surplus. So no. And will oligopoly concept used in real time by ISO for solving ED? Oligopoly concept is a different. Market clearing we discussed. So market clearing is being used by the system operator, not system operator, market operator, I would say. Okay, so market is being cleared by the market operator, and as I explained, there are three market operators in India. Okay, so the market operators basically perform the market clearing algorithm, and they come up with the market clearing price. But if let's say remote power plant is there, mm, maybe a solar plant in like remote area in Rajasthan, and a transmission line is basically built there. And let's assume the transmission line is double circuit line. Okay, so and assume 50 megawatt 50 megawatt is being produced like carried over on those two lines. If one line goes out, uh, so 50 and 50 100 megawatt we can transfer. So I'm just hypothetical case, so 50 and 50 100 units we can transfer from the power plant to the let's say load centers, and we can say that it's also participated in the market. So market has been cleared, and it said that okay, the particular power plant will produce 100 units, and there is a line which can transfer the 100 units from the generating power plant to the rest of the network. But uh, due to the transmission outage, let's say one circuit goes out, on only one line is available 50, so instead of 100 units only 50 units can be transferred. In that case, the quantity has been reduced, and if quantity has been reduced, you will see deadweight loss again. Okay, so that is part of the market clearing, and those are basically part of the settlement. So yes, but it won't be called as a abuse of market power and we are setting a higher price. So yes, if for economic dispatch, uh, yes, system operator perform market clearing, and they go with the least or the like profit maximization objective or the cost minimization objective. And oligopoly is nature of the entire market. So it's a basically how you model the system. Okay, now if we talk about the GAMS, General Algebraic Modeling System, so it's a software. You can download it, and I have shown you like it's very simple to download. A demo version is available. There is certain limitation that how many variables you can solve with the demo version, and how many equations you can have in the demo version. But if I so yes, it's visible. So I will quickly go through this like the introduction and how we can use the GAMS, and then we will try to solve a simple problem first of all, and then we will try to solve market clearing itself. Okay, so I will come up with certain example and we will try to solve it. Okay, so GMS is a modeling tool for mathematical programming and optimization purpose. So we perform optimization, and it's very good and robust optimization tool. It can be used in solving different types of optimization problem. It can model and solve linear, non-linear, mixed integer, and different other types of optimization problems. So there are vast types of problems are available. So if Okay, I have shared the screen with you. So if you go there in help and licensing, so if you have license, then the full license will be available here. So are the servers positions has been changed? No, but the by default server should be available, right? Okay, in demo version it is not available, right? Okay, fine. So okay, fine. So it can solve different basically variety of problems. And so what is the benefit of going with it? It's basically this model, games model is concise, and it makes full use of the elegance of the mathematical representation. Like, the way we write down the mathematical problem, uh, this software also write it down just kind of a similar way. And even if you write it down on a page or in your notes, and you can also write it down in the games as well. Data can be entered in most elemental form. Okay, very easier as well. And the model is portable. It can be used, like in different computers and with the different models. So these are the elements of the games code. So only these 4 5 elements are there, not more than that. So first is sets. Sets are basically used to define the index in the algebraic representation of the model. Usually, like generating units are there. So instead of defining multiple generating units like generating unit 1 2 3, we can define all together by a particular index. That okay, this I is the index of the generating units, and there are 4 generating units in that. Same goes with the like network buses, slack buses, as time periods. Those can be defined in set and very easily. We will discuss it how we can define these. Then how to provide input data. So we can provide input data by 3 means. One is like parameters, tables, and scalars. Okay, so parameters and tables are defined over the set which we have defined in the very first. So the sets we have defined, then input data, the parameter and tables will be defined over the sets. Then we will variables are the like decision sets and are unknown, so we will define those as well, because it needs to understand that what are the different variables. Then we will write down the equations. Basically simply write down the equation, uh, exactly same as we are writing down writing it in our uh, notes basically. Okay, then there are some model and solve statement, what you want to do and what you want to solve, and then some output will be visible. So this is the structure of the games. Okay. So first of all, sets, we declare sets and then assign the members in the set, that how many members are there in a particular set. So Shilpa, there are many solvers available. Okay, and in demo version I'm not able to show you, but if you simply google like solvers available with games. There are many solvers like Ciplex, Gurobi, Conopt, IPOPT, Baron, Mosaic. So these are few which are basically here. There are lot more than these solvers, but the issue is you have to pay for it. There is no crack version for it, so that is the issue. So if you have a licensed version, it's better to use games instead of like doing programming in MATLAB. But yes, like Ciplex is for the linear programming, IPOPT is interior point optimization based solver, and this Conopt is I think for NLP, non-linear programming. So based upon different problem type, whether it is linear programming, mixed integer programming, or non-linear programming, we can use different solvers. So now Okay. So variables again. So input data, we will declare the data, and then we will assign the values to this particular data. So the input data, as I explained, there are tables, parameters, and scalars. Three types of data we can provide. Then variables are can be like positive variable, negative variables, integer variable, binary variables. Different variables are there, so we have to declare those variables, and then we will assign some values, are basically type of the variable, whether it is positive, binary, integer. So assignment of the type, because variables are unknown, so we cannot assign the values to the variables. It's only type we can define. Then as if there are some bounds like lower bound and upper bound or some initial value, uh, in this case, then we can assign those as well. Then we will write down the equation, like we will declare the equation, and then we will define the equation. So we will go everything in detail. How the What is the syntax for sets? So let's say there are two sets, I. So if you see in the bottom, red and green color, basically codes are given here. So this red, you should have to keep it in the games. It understand the red. These are basically syntax of the games. The green one is basically user inputs. So if I just go back to the very just above this one, set G. So G is the name of the set. I can give any name here. It's a user input. So that's why it's a green. You can give any name here. So I have given G as the name of the set. Now description can be anything again. It can be a very long description, very short description. I have used here single word description. Even I made a spelling mistake as well. Like instead of TOR, I just type TRS. So you can write anything. Okay. So it's a description. So like in this particular part, description is single word. If you see this like first line, canning plants. So the description is of two words. You can have description of like 5 6 or a line as well. Okay, so a long description can also be there, so it's easier for somebody else to understand the code as well. So that is the good thing of the games. Then this red basically slash are mandatory, so these has to be basically provided, and within these two slash and a semicolon, you can provide index, or usually in set we can we also call them members. So like like canning plants, like the very first example is set I. There are the description is I is basically canning plant set, and the locations are Seattle and San Diego. So I can name it like any words. So like Seattle, San Diego with a dash. It again, it still works perfectly fine. Like set J is basically different markets for the canning product. Okay, and then the in the backslash, basically if you see there are three markets, so the New York, Chicago, Topeka are the basically markets. So you can put those by the names as well. Another way of doing is, let's say I have to mention 24 hours. Okay, so I have defined a set T, which is, so this set is fixed, this is red, then this is a name given by me. You can give time, you can give double TT, triple T, or T123, whatever you want to give. Then you can define it, whatever words you want to use to define it. Then in backslash I have given 1 and star 24. It means is equals to 1 2 3 4 and up to 24. So there are basically 24 values. Okay, so these like members can be defined in different ways. Like again I have defined time, and I have mentioned m1 star m24. So here m is constant and 1 2 3 4. So the members will be m1 m2 m3. You can define t1 t2 t3 as well. So whatever you want to do, basically you can define it as per your convenience. I have defined another set which is also time, but I have defined the name of the set is month, and the description can also be month, but I have placed months s with a s, and I have defined Jan, Feb, March, and June. And if you can see, I am using uppercase, lowercase, all combinations basically. So it's up to you how you define. Okay, it doesn't matter to the games. Similarly, like generators, I have defined G12. G5. So this is how we define. Another command is alias. In the last, you can see. So let's say some time set T is being defined, and then you want a copy of that, so you can make alias of that particular. So TP is the same T set. Okay, so sometimes we need those. Now we talked about like the input data. So we discussed there are three types of data. One is like scalar, parameter, and tables. So first of all, if I talk about like scalar, so you can see at the bottom the like syntax. So the red colors are mandatory. You cannot change them. So scalar, I have to write it down like this only. Then scalar name. So it can be anything, whatever name you want to do. So like here if you see, so if you see, I have used PRI as the name of the set, not P, not price. I used PRI the name of the set. Then the description I have mentioned is basically this. So instead of single word description, this time I have mentioned a long description, that price in rupees per unit. So this is what I have mentioned, the description of the this particular scalar. And then in backslash, basically in the slash I have mentioned 5. It means I equals to 5. This is the meaning of it. So like the scalar is defined that okay. So this is how can I, okay, leave it. Another way is like, let's say instead of defining single scalar, I have to define multiple scalars. So I can define like I will put this scalar. This is the syntax. So this needs to be there. Then scalar name. So this A is scalar name. Then I did not describe any description here. So description is removed. So you can also, like, if you want to put description, it's better if somebody else read the code. And let's say in future, if you want to revisit the code for you as well, it will be easier to understand. Okay. So so it means A equals to 3, then F equals to 7. Then I defined some D with the semicolon, and I did not provided any value here. So what I can do is I can assign or basically calculate the value of D equals to, let's say, A into F. So I can also define scalars like this. Okay, so there are different, these are the like 2 or 3 ways of defining the scalars. Now, if we talk about like parameters are basically, you can say, a single array. Okay, so this is the again syntax. If you see, this is a parameter. Okay, so if you see, this should be mandatory. So I have placed parameter as a mandatory part. Then parameter name. So if an array is always indexing, like like in MATLAB as well, we if we have array, let's say B, so B1, B2, B3, B4, these are index. Here the good thing is index are not 1, 2, 3. It can be 1, 2, 3. It can be something else. So like the parameter name. So the second part is parameter name. So the parameter name is D. So I have defined parameter name D, and the index I gave is month, which I defined earlier. So a month, and then description part is basically, if you see uh, the description, okay. So the description part is defined here, demand in months in megawatt, and then in basically a backslash, I have defined the index. So month, the Jan month has 300 demand, Feb has 100 demand, March has 50 demand, and June has 2000 demand. So need not to be in sequence as well. That's why I omitted April and May in between. It's a you have complete freedom. Okay. Then so this is how we can basically define the parameters. Now, if we talk about the table, so if you look at the syntax, this red part is again fixed. So the table name. So again, I have defined the table name as a D here. So a table always have two and more number of index. So far, for today's class, I have only considered two. So it's a row and column. So I have to give two index. So I have give one I and another is J. So this is index I and index J I have provided. Then description is distance in thousands of mile, and let's say that is the description. Then I have to type the entire table here. Okay, there are other way of exporting getting data from the Excel as well, but usually I prefer writing it down in the code as well. So like New York, Chicago and Topeka are the markets, so that is the J index. Seattle and the San Diego are the production cities, and the distance in basically thousands of miles is provided. So you have to draw a table like this. Then it means Seattle to New York distance is 2.5, Seattle to Chicago is like 1.7, and so on basically. So different distance are available here. Okay, so this is how we can define tables. So these are the three ways to provide input data. There are other ways as well. So like sometimes I don't have any basically what I say note does not know that what many parameters I'm going to use. So sometimes what we do is we define with a star as well. So this is like table is the our syntax. So this table part is the syntax. Gen data is the name of the table. Generation number is the index. Okay, the set index basically, and the numbers are basically the cities where the five generators are placed, and then star is placed. So I can put different index here. So B is, let's say, cost function. P min is the minimum production. P max is the maximum production, and this is how I can define the table. And sometimes what I can do is I can set a character. So I can define a set. The name is character, and in this character name, so like in this set we have B, P min, P max. So if I have defined this earlier, I can directly write down the table like table gen data, generator number and character. So these are the two sets, generator number and characters, and these are the members in the set generator number, and B, P min on P max is the members in the character characteristic set basically, and these are the values again we are placing. Okay, and then there are different ways of that this is a three-dimensional matrix like the table. Here you can see 1.2, 1.4, 1.5. So one is we have basically four nodes. One, so there are two generators at bus 1, and 2, 3 and 4 are the bus numbers. So and then node numbers are 2, 4, 5, 3, 4, 5, and then in star we have placed x and limit. So this is a three-dimensional matrix as well. So this is how we can place. Now how to define variables? So variables are again this is a syntax. So like variable name is user input index you can provide, or it is optional. Maybe some variables does not need index, and then some description. So it is just declaration of the variable. Then we have to define the variable as well. So like here I am declaring the variable. So this is basically declaration, and then this is where we are defining the type of variable. Okay, we are defining the different types of variable, whether so by default different types are available. So the free variables are basically they can vary from minus infinity to plus infinity. So they are basically real numbers. Then positive are basically 0 and to infinity, negative is 0 to minus infinity, binary is 0 1, and integer is simply 1 2 3. So you can define the different variable types, and to define you just have to write down these keywords. So like positive variable, and just put the variable name which is positive variable. So if I ask you what will be the type of variable m. So in this declaration I have defined two variables, are basically declared two variables x and m. uh, can somebody give me like what will be the type of variable m? So there are two variables x and m, right? So x is defined positive variable. Anyone, what will be the type of variable m? Yes, so it will be free variable because it is a default variable, and until unless we define positive negative binary integer, the all the other variables will be free or default variables, right? Default type. Then equation. So again, this is basically the declaration of the equation, that we are declaring that we have three. We are going to have three equations like cost, supply with multiple indexes there, demand as multiple indexes there, and then this is the description of the equation. So it can be anything again. So this is just declaration, and then this is how this is the notation for the declaration of the equation. So this is the declaration of the equation. Now assignment, how we can do it. So if you see here, okay, wait, yes. So here, if in red, if you see, sorry, black color, I have declared some equation 1, equation 2, equation 3i. So this is the declaration. In declaration, I can declare like this, that equation name, and there some description. Description is again always optional. You want to put description, it's your choice. If you don't want to put description, that is also fine. So here I have not placed any description. I just declared that I am going to have three equation. Similarly, maybe some other names are there. Then this is how I'm going to write the equations basically. So like I have declared a equation eq1. So eq1 then double dot. So this is the syntax of writing equation. So eq1 double dot is the syntax. Then I will write down x plus y equals to, so this equals to, and e means equals to. So this is a syntax that you have to make sure how basically we can. So this equals to between e between 2 equals to is equals to uh, L between 2 equals to is basically less than equals to, and G between 2 equals to is greater than equals to. So this is how we write down the equations in just simply this is how we write it down in paper. But yes, obviously like we have certain symbol, mathematical symbol. Here we are not using those mathematical symbols. We are replace those mathematical symbols with equals to, e equals to L equals to G equals to. Now this side part I will come back again. Okay, so this is again the structure of the, like we can provide the input like set, variable, tables, scalar, parameters. Then we will define certain equations, and we can create a model with different set of equations. So let's say equation 1 and equation 2 is used to create a model 1, and then different equation 1 and equation 4 is being used to create a model 3, and so multiple models can be created, and then we can solve these multiple models. So in a same problem we can skip, or basically you can write down all the equation, then you can accommodate only few of them to solve a problem, and you can accommodate all of them to solve a particular problem. So this is the model statement. Usually, like the red color is basically fixed. So we will write down model, and we gave a name of the model. So this transport is the name of the model. So model name is transport. In backslash I have written all. It means before this line, whatever equations I have defined earlier will be considered to, or will be solved in this model. And otherwise I could have mentioned certain equations, so like this. So if you see, like the model is the syntax, the name of the model is model 1, and instead of writing down all of these equation I have given equation 1, 2 and 3 as a basically like, so I have written equation 1 to equation 6. So I have created a model where only three equations are there. Then I created another model, model 2, where I have equation 4, 5 and 6. So you can have, and you can also put, let's say like here I can put eq1 as well. Equation 1 can also be placed here. It need not to be like, separate equations. They can overlap in different models. So this is how we can write down. Then again, the soul. So now we will write down soul. uh, what to solve? So we have to solve the transport model. We have defined a model, so we have to solve this transport model. uh, how to solve? So we have to define using linear programming. So these are the basically different procedures. So depending upon the type of problem, we can use linear programming, NLP, MIP, MINLP, and there are others as well. So I have placed LP. Then what I want to do? So either I can minimize or maximize. So I have placed minimizing, and I have placed certain variable Z which I want to minimize. Okay, and then display is optional. You can display certain values if you want to. So let's say this is an example. So I ask everyone, my drawing is not good here, so I ask everyone to basically use this particular example. And we have drawn a market clearing earlier, this one. Okay, so can you give me market clearing price and market clearing quantity as per this concept from this particular data? You can also solve. I have not solved it yet. Okay, so you can also solve it. Who's trying? If you have any doubts, you can raise your hand. We will unmute you. Sir, I have attended at a later time of the webinar. Please explain how to solve the market clearing price. Okay, fine. So just to tell you that we are going to do a lot of hands-on and the programming basically in MATLAB as well and in games as well. So I if you have not watched the videos, I think in WhatsApp group we have shared the link. You can go revisit the recordings and see it. So okay, let's solve it. First of all, can somebody remember these? Yes, so there are four generators, each of 100 megawatt. So each generator is basically offering that they can produce 100 megawatt and at the rate of 10, 20, 30 and 40 US dollars. Okay. So and then 150, 100, 150, 100, 60, 35. So I will revisit here. So let's say let me draw it here. Okay. So how to put grid here. It's okay. So this is what we have drawn on x-axis. What was the on axis? I forgot basically. Somebody help me. Quantity, right? And on y-axis it was price, right? So we have 100 megawatt quantity, and the prices were already sorted in the increasing order. So that you will the system operator or basically market operator will receive the bids. So we have to sort them in increasing order of the price. So we have done that. So let's mark. Let's say this is 10, 20, 30, 40, or it will be let's say, let's keep it 10 here, 20, 30 and 40. Insert space. Okay, then okay, and if I go back, extend the y-axis. So at 10 megawatt we have a certain quantity of 100. So this is 100. Let's say this is 100. Is it visible? Right. Then the second generator is producing 10 megawatt, but at the price of 20. I will stick it here. So this is 200. Then we will have it up to 300, and let's say this is 400. So at price of 40. So these are the generator 1, generator 2, generator 3 and generator 4. What was the buyers? So buyer 1 is 60, 35, 25 and 50. Okay. So let me draw it. So let's assume 60 is here and the quantity was 150. So I will draw up to this part. Okay, roughly around mid of this. So this is 150. Second is 100 and the price was 35. 35. So 35 will be roughly around 10, 20. This is 30. This is 40. So this is 35. So I have to come down up to here, and the quantity was 100 megawatt. So 150 and 100 will be 250. So we came to 250. Then next quantum was let me go back. So it was 150 at the price of 25 and 100 at the price of 15. So 150 at the price of 25. So 25 will be roughly around here. So I can draw it like this. And 250 and 150 is 400. So I can go up to 400. Then next is at 15. So I will go 15 and next 100, which is roughly around here, which is 500. You can see this is the market clearing point, and the quantity being cleared is 250, and the price intersection point is 30. So this is market clearing price is equals to 30. Is this okay with everyone? ये हमने समझ लिया. Okay. So the 30 is the market clearing price and 250 is the market clearing quantity. Now we discussed consumer modeling and supplier modeling, and I explained you that consumer wants to maximize its surplus. Like we had that lamp example, and we decided that how much a consumer is going to consume if a certain market price is there, and we came up to I think 7 lamps. Okay, so that is decided by maximizing the consumer surplus. So we keep on increasing the surplus, and after like seventh lamp, at seventh lamp the surplus was 21, and on eighth lamp the surplus reduced to 20. So the we basically maximize the surplus. So how can I maximize the surplus here? Okay, so okay, now how to model it mathematically, so that we need a mathematical model to put in games, right? This is our problem, and we have to model it. So which area is surplus? Can anybody give me the like surplus data? So this area is the surplus. So this okay, this is our demand curve, downward slope, and this is our supply curve, and the area between demand curve and supply curve is the surplus, right? So if I want to write it down in mathematical form, how can I do that? So it is very simple. It is the basically difference between um, areas of so it's like we want to maximize. So the objective is maximize the money which we are basically getting, or whatever is the utilities willing to pay. So that is the utility willing to pay. How much is utility willing to pay? I can say what was the price 60, and let's say demand 1. So I don't know what will be the scheduling demand. So, how much quantity is being will be scheduled. Then plus what was the second term? 35. 35 demand 2 plus 25 demand 3 plus 15 demand 4. So this is the expected, or basically demand willing to pay this much basically utility, or this is the utility of the demand. Now we have to subtract the cost. So cost of production is basically from the buyer side. The prices were 10, and we don't know whether they have scheduled, or they are willing to produce 100 megawatt. We don't know how much they will be producing. So like if you see here, generator 1, how much generator 1 will produce? This is the market clearing quantity 250. So this everything on this particular side will be basically the cleared or scheduled, and whatever is on this particular side, so I will mark it in red color, will not be cleared. This side is not cleared, this will be cleared. Basically we will have a schedule. This is cleared, and this size is not cleared. So generator 1 will produce 100, generator 2 will also produce 100, and then the quantity is 250, so this quantity is 50, so generator 3 will produce only 50 megawatt. But same, if you talk about the demand point of view, so this first term was 150, I think. So the demand 1 will be getting 150 megawatt, demand 2 will be getting 100 megawatt, demand 3 will be getting 0, demand 4 will be getting 0. Generator 4, which is beyond this market gaining point, so it will be producing actually 0. So it is willing to produce 100 megawatt, but after the market clearing performed, algorithm is being performed, the output should be 0. Okay, so we have solved this one. And so how to model it in mathematically? So where is the cursor? Yes. So if you see here, 10 p1 plus 20 p2 plus 30 p3 plus 40 p4. This is the objective, right? I have to minimize or maximize it. I have to maximize it. So I have to maximize the utility of the consumer demand, and I have to it's a minus sign, so I have to minimize the cost of the suppliers. Now, subject to the condition, we discussed it earlier that electricity cannot be stored in bulk quantity, so it has to be uh, consumed at the time of, like, whenever we are producing it, we have to consume it at the same time. So power balance has to be maintained. So I will write down a power balance equation like P1 plus P2 plus P3 plus P4 equals to D1 plus D4. This is the equation. Now, if I look at the limits, the P1 generator gave that, okay, it can only produce 100 megawatt. So the P1 will have that, okay, I can only produce up to 100 megawatt. And same goes with the other generators as well. So like, P2, uh, P3 and P4 all are basically having the same limit. D1 has the limit of 150, that demand 1 offered or basically given a bid that it it can consume 150 megawatt at a price of 60. Similarly, D3 as well gave the same demand, and I can say D2 and D4 gave that, okay, they want to consume 100 megawatt. So this is our model. So this is what I have written here. Now I try to write it down in games. What was the first term? Set. So I will not write down set for this very simple problem because I have not defined any set. When we are going to solve economic load dispatch, we will discuss the sets. So first of all, I will define the scalars. So if you see, just for your sake, I have already written it. So these are the values I have defined. So like the C1 is the cost of the generator 1, C2 is the cost of generator 2, and I have defined that it is 10, 20, 30 and 40. These are basically 10, 20, 30 and 40, you can see. Okay. Can I zoom it more? No, not more than this. So then demand 1 said that, okay, he is ready to spend 60. Then demand 2 is 30 or 35. 35, so I will put 35 here, then 25 and 15. So this is what I have defined. Then next part is, so we don't need to define sets here because we are not using any set. Then the second part was like input data. So input data was so as there is no sets, we don't have any arrays or tables, so we are not defining those as well. And I'm not giving any description. I can give a description as well here, like, this is the cost or supply bid price of generator 1. So I can put a description as well. So let's say like for first generator I have placed that C1 is the supply bid price of generator 1, and you can put the description for others. And as mentioned earlier, description is not optional, but it is good to put them. It is good for you just to understand. Now next part is like variable. So I have defined a variable objective. Okay, so it's a new variable. Then I have defined positive variables. So okay, can the demand be negative? uh, no. Can the generation be negative? So no. And I'm assuming that the minimum limit is 0 on the demand and generation. So I have defined them positive variables. So I have defined P1, P2, P3, P4 and D1, D2, D3, D4 as a positive variable, and I have defined a variable objective. Then next part is I have to place limits. So I have placed limits on P1, P2, P3, P4. The upper limits are basically 100, 100, 100. And this is a very brute force way of doing it. We can write a very simple and very good looking, I think very few lines of code. So but just to understand everything, I have written it as a very like crude way, I would say. So this is what I have mentioned. Then demand as well, I have mentioned like D1 is 150, D2 is 100, D3 is also 150 and D4 is 100. Then next, this input data has been completed. Now we have to declare the equation. So I have declared that I have two equation, equation 1 and equation 2. You can give any name. Here I have used equation 1. I can say equation 1 obj, and I can say equation 2 uh, power balance. Okay, so let's say you can put any name. Need not to be equation as well, like I can say obj function, and let me remove equation 2 as a power balance. So these are the name of the equation. Now the syntax is whatever name we have defined, I have to put it here. So obj fun is the name which I have given to my equation. Then I have to place two dots. So this two dots is basically syntax. We have to place it. Then I think I made a mistake. Let me define power balance first. Okay, so you can define in any order. So I have declared objective function first and power balance second, but I'm writing down power balance first and objective function second. So you can do it in any order, it doesn't matter, and it won't affect the outcome. So I have like this is how we have written it like this, that P1 plus P2 equals to D1 plus D2, D3, D4. And the same way we are writing down here, P1 plus P2 plus P3 plus P4 is equals to D1 to D4. The same way we are writing it here. Then I have to maximize this entire term. So what we did is we assumed it is equals to another variable, and the name is given obj or objective function or obj, let's say. So this entire function is obj. I have placed it here that obj is variable which is equals to c1 p1, c2 p2, c3 p3 and c4 p4. Okay, and then minus a1 d1, a2 d2, and d4. So this is what the entire equation. Then I know that this is a linear problem, so I have model. Model is a keyword. So you can see here, like if you write it down in Game Studio, you can see the color coding is there. So if like different colors are there, so these like a positive variable equation they have in blue color. So this is basically the syntax part of syntax. So you have to be careful with it. So let's say like if I write down model G, it will go away because there is no syntax model G. I have to put model as a syntax. Then I gave a name. So let's say and give it name market clearing. Market clearing, I have gave the name, and I am modeling all the equations. So I have only two equations here, so I have written all. here. Uh, then I have written sold, and which needs to be sold. So the problem is market clearing needs to be sold. Okay. What is the method? Linear programming. So the procedure is linear programming using LP. I can write minimizing the full, or you can use the short as well, like min and max. So I am basically minimizing the value obj. Okay. And simply run button. So I have not used display. Once we run, you can read it here that status is normal completion. If I click it here, this lst file, new one.lst file opens. And if I go to the solution report, it says model status is normal completion and the solution is optimal. Okay. Now if I look at the different values, so this is how the values will look like. Let me delete this one. So we have defined different variables, right? So one obj was a free variable. So if you look at this, obj is free variable, others are positive variables, right? So obj is free variable, so the lower limit of variable is infinity, upper limit is also infinity. Then we have defined p1 as a positive variable, so this dot represents 0. So that is a special thing. If anything is represented by dot in games, it is actually 0. So this p1 is lower limit is 0, upper limit is 100, and the solution is 150, 100 p1, 100 p2, and 50 p3. Similarly, d1 is 150 and d2 is 100. Okay, and this is what we have basically obtained from here as well. 100, 150, 100, 150, and 100. Now, what will happen if I increase this price to 33? So it's your assignment, not assignment like you have to do it right now. So let's say this demand 3, which is at 25 right now, is being increased. So this demand 3 is basically D3 is basically how much? 150 megawatt at the rate 25 it was earlier. Now I have changed it to 32. So what will be the market clearing price and market clearing quantity? Can you draw it? If these changes has been made, what to use up after each positive variable? Why to use up? Uh, yes, we will discuss it. So, are you talking about this? Kush, please unmute Shilpa.
Good evening, sir.
Good
Hello, am
evening.
I?
Yes.
Yes, sir. My question is, we are using each time for each positive variable when we are declaring it p1 dot up, p2 dot up. So why to use dot up? Is there any significance of it in
Don't,
using in
okay,
games?
okay. I did not explain you this.
Yes, yes.
So these are basically bounds we have defined. So if you see in my PPT, I have certain variables. Okay.
Yes,
And
sir.
these variables basically can be defined with certain limits as well. So like, variables, we have always have limits. So this UP is upper limit.
Upper bound.
So,
Yes. Okay.
so this is basically upper bound. So UP is upper bound. So P1 dot up is basically P1 variable. The upper bound of P1 variable is 100.
Okay,
Let's
sir.
say I have a lower bound as well. Let me define lower bound as well. Okay, let's make it interesting. Let me define P3 का भी कितना solution आ रहा था हमारे पास में? It was 50 megawatt, right? Let me define lower bound equals to 70. So if there is no limits, uh, the solution which we obtained is P3 equals to 50. Here you can see P3 was at level was 50. So these are the limits and the actual level is 50. Now if I change the lower limit to 70, that it can only produce minimum of 70, and our market clearing is giving us answer of how much? 50.
50.
So then solution should not be feasible. So let's see. I don't know what will be the solution. So the report is normal completion. I will click it, and LST file will
Yes.
be open, and P3 solution is basically 70 now. Okay,
Mhm.
but so it is
Mhm.
possible. That is the important thing. So if we go back to the market clearing, uh, this generator is still producing. So the price is defined. So market clearing price is still 30. This is the intersection point.
Mhm.
Okay. So if you look at the result, the market clearing price is still, uh, where is the cursor? Yes, it is still 30. So at 30, instead of producing 50, the demand is producing how much?
70.
70 megawatt, because it can produce a minimum of 70. In that case, uh, this 150 and 100, 250 demand is fulfilled up to this part. This extra 20 will be
Mhm.
given to the third demand. Okay, because
Mhm.
but the price for this is still 30. That is the issue. So if you see here, the result part 150, and the third demand is basically at
Yes,
20
sir.
megawatt. Okay,
Right.
okay, and
Okay, sir. Mhm.
one more thing is, like, if you go to solve equation power balance, and yes, and if I remove it and run it, so you can play with it, like, you can do different variations with it, and then you will get to know different results. I can still observe multiple results, but I'm not explaining those to you. I recommend whatever we have learned today, you manipulate this code. And nobody asked me that, okay, here the objective function is of maximization of objective and 60d1 plus 35d2, and I have placed it here is like minimization of objective, right? So the difference is, I have completely shuffled the objective. It's like, cost minus utility, like utility of the demand. So that's why I'm minimizing it, and here I have written utility minus the cost. So that's why we are maximizing it here. Okay. uh, so what will happen, like, if you know ना do different variations, let's say अभी हमने एक एग्जांपल लिया था, आपको सोल्व करने के लिए बोला था. Are there any push check the chat please? Yes, yes, so it's an inverse function, like multiplied with a minus, so maximization will become minimization, right? I have asked you to, like, solve it, this particular problem, when the price or the asking price for demand D3 is being increased from 25 to 32. What will happen? Anyone? 32 is here. So instead of going down, this demand curve will move in this particular direction from here up to this part. Let me erase. So the demand curve will go from here to here as 32, and then it will go up to 15, which is here, and this will be the new demand curve, and we can get rid of this particular one, let's say with a yellow, that this part is no longer available because the price has been shifted from 25 to 32. In this case, the market clearing will also shift from that a point to this particular point, and the cleared quantity will be 300, and the prices will be 32. Do you guys understood this part? If you have any doubts, please ask me. Can we obtain the same results from the games code as well? So if we shift there, generator 3, like with the modified one, P1 will be 100, P2 will be same, repeat 100, and P3 instead of 50, it will go up to 100, and D1, D2 is like same, 150, 100 demand, right? And the third part is basically this much power, which is 50 megawatt, I think. So D3 will be equals to 50, and market clearing price will be equals to 32. So let me see from this code. I have to change the this part 25, make it to 32. That is the only change we made, and let me run it. So once I have solved it, I will look at the variables, and if you see 100, 100, 100, 300 is given here, and the demand variables are 150, 100, and 50. One interesting observation is this. So a market clearing price will be basically 32. So we will discuss in the next class that what is the significant how to obtain the market clearing price. But from just for today's point of view, like whenever we are writing down this power balance equation, okay, so this particular power balance equation, the dual variable, or generally we call it simplex variables, right? Simplex variable of this particular equation is equals to the market clearing price, and this is also called marginal value, marginal value of equation, and usually the power balance equation. So this equation is a power balance equation. So the dual variable, simplex variable, or the marginal value of a power balance equation is equals to the market clearing price. So this, it can also be seen from here. So if you see here, if I go on the solve equation, look at the power balance equation, everything is satisfied because it is equality constant, and the marginal value of this equation is 32. You can see it here. So if it is 32, it means the market clearing price is 32. Again, if I come back, like and make it at 25, the market clearing price was 35 earlier. Earlier it was 30. So let me run it and check. So what is the power balance equation is saying? And if I say the market clearing price is equals to 30. Okay. So the price has been increased from 30 to 32 market clearing price. Quantity will also increase accordingly. Okay, and this is how we can basically write the entire program. Now I will just quickly go through this lst file, what it is basically. Whatever you have written, your piece of code with the each line number will be displayed first of all. So this is what we have written earlier. Then it will do this like entire detailing, that what is the compilation time, how much is memory required, and basically sold market theory using LP linear from line 47. So on 47 we have mentioned it, so we are solving it from there. Now how it reads everything, this is also important. So first of all, it will read the equation 1, and the first equation was objective function. So objective function is like this, will read objective function minus, so everything will be like will be brought to the left hand side. So you can see here like the 10 p1 10 p2 and all these values basically. So c1 is already given, c1 is equals to 10. So this 10 p1 20 p2 30 p3 40 p2 p4, everything will be brought to one single side. So this objective is minus 10 p1 minus 20, everything is brought on the one particular side objective function, plus this, and you can see is equals to 0. So this is the equation 1. Okay, so we have written objective function like this, and this games will bring everything on the left hand side and keep the constant on the right hand side. Then for the power balance, let's say power balance equation, it will give power balance p1 plus p2 plus p3 minus d1 minus d2 minus d3 equals to 0. So everything is again brought back to the left hand side. So LHS equals to 0. This is how it looks at the equation. Now equation has been read. We already read the equation. Then it will solve these basically. Okay, so it has been solving them, and different values are there. So dot, you can see it is basically what is the lower value of p1, what is the level which is actual value of p1, what is upper value of p1, and what is the marginal value of p1. So initially it is given, so this is basically initialization, that what is the initial values provided there. So initially it is 0 0 100, upper value is 100, initial value is 0 is given, but it will come equals to 100. The final solution is 100, but the initial value is 0. So these are the initialization of different variables. Okay, so lower, what is the actual level, what is the upper value, and then what is marginal value. So these are the given here. Then again this will convert it into something, it range like solve it. It will provide the different datas, that okay, how many equations are there. So two equation, single equation, two equations are there, number of variables are 9, single variables are 9, so non-zero entries are basically 17. And so this is the entire data sheet, like what are the different parameters and variables and equations. Then it will provide you a solving summary. So like model, which model is being used, okay, and how the solver, what is the solver status, what is the, whether the solution is optimal or not. Okay, everything is provided here. Then so it is linear programming, so it gives you the information that the solver was simplex. So the games used simplex solver, and but you can also define, like some different solvers if you want to solve it with some different solver. Okay, then optimal, it provided optimal solution is find, objective is minus 8000. So because everything is brought back on the one side, so objective function value was minus 8000, because we are minimizing it. And if we go with the, like the one which we have written here, it will come equals to 8000, which is also fine. Then the different values are provided, so these are the equations. So the level should be 0, so it is exactly equals to 0, and the marginal value gives the market clearing price. Okay, and then different variables are defined. So these variables we have defined, what is their level. So objective function is 8000, and then p1 p2 p3 and p4 is 0, d1 d2 is given, d3 d4 is 0. These are lower and upper limits which we have mentioned, and these are some marginal values. Okay, So higher the, from the demand point of view, higher the marginal value, it means cheaper is the generator. Okay, so this is we have defined. Then non-optimal, infeasible, unbounded, everything is zero. So yes, our solution is completely fine, because sometimes it's solved in multiple iterations. So how many iterations are non-optimal or become infeasible or unbounded? So this information is provided here. Some execution time and the license. So we are using a demo license for the time being. So this is what the input file was, new one GSM, and the next file is LST is the output file. So everything is here. We can export these with the Excel sheet as well, and we can import the data from Excel as well. But these two files will be provided to us, and we will basically write the code in .gms file and get the output in .lst file. If you have any doubts, please ask. And so this is it from my side for today. So we have understood how the games work. Sorry. Any doubts? You can either raise your hand or you can write in the chat box. For optimization theory, I will explain everything. Books for optimization, I have no idea, because read a lot of books and I don't know which one to refer. I will suggest you, but basically, the optimization books which I am being reading are more towards the like power markets or power system or smart grid system side. So if you simply search optimization theory, or if you are in engineering, there is a advanced mathematics there also, books are available. And Fletcher is one of the book. Yes, like for optimization, different for this particular course, we can refer the book Wood and Woolenberg. Kush, can you put that into the chat, the book's name, or if some image is there, you can share that as well. Wood and Woolenberg. So that is the book for power system operation, and it also has modeling and how to model the system. What are the different I think linear programming, nonlinear programming, everything is available in this book as well, so you can go through it. So for this particular course, I think this is fine. And optimization for engineering design can be useful, yes. One RD Fletcher is there. It's a very old book, but for I would not recommend to start with that one. I would recommend go prefer some easy books in the very beginning. And very fundamental optimization, we also learn if you have maths background, like linear programming, simplex method, those fundamentals are being taught in 11 12th as well right now. So those books are also very good for just to begin with. Any doubts in games? So I request everyone that we have written down a code today, this one, right? So this entire model can be written differently as well, and I think it's better if you can, like take the help of Chat GPT. So these tools are for our help only. So I would recommend you can take the help of the Chat GPT. And let me give you the same model in different, like let me write it down in different way. So maximization of obj equals to summation over s equals to 1 to 4 uh, some we use c and a, right? So I will write down here c s, we are maximizing, right? So okay, wait. So I have used a variable as note again. So first of all, we have demand. So let's say d equals to 1 ad, and instead of capital D, should I use n? I use कर लेते ना. I equals to this. So AI, these methods are exact method of optimization where these methods are exact method for optimization, whereas Professor Karan Moidev's books is on evolutionary optimization. I will refer some books definitely. Okay. So AI and DI. So this is how we can I can write down, summarize this entire part. Okay, we have defined A and D. So this is summation of 1 to 4 AI and DI minus, let's say, summation of J equals to 1 to again I have 4 generators, so 4, and I have CJ and PJ. Then I can put the equations like this, subject to what was the equation, that summation of J equals to 1 to 4 Pj equals to summation of I equals to 1 to 4 uh, sorry, it should be Di, right? Di. So this is our power balance equation. Then we have limits. So for limits I can put Pj less than equals to some P max J, and I will write it down like for all J. And another is we have demand as well. So I will write down Di less than, and let me put 0 as well. Positive, this is positive variable, right? So D max I, and for all I equals to 1 to 4 equals to 1 to 4. So this is the way basically we can, the another way of writing it in terms of sets. And in the next hands-on of on the games, I will start this sorry, this one just to like we have written a brute force uh, method, brute force we have written in a brute force way for this market clearing. But what if I write it like this, how the games code will look like, we will discuss, so that we can start using it for economic dispatch and DCOPA, which are like much complex problems. So this is it from my side. uh, So thank you very much, and we will, tomorrow 10 o'clock again. If you have any doubts, you can also email me. So this is it. No doubts are there. We will have the programming in the morning session. No, I think there is a timetable. So we are going to follow that timetable. So usually what I will prefer is basically, taking some theory in the morning, and then repeat like on the similar topic. We can do the programming or hands-on in the evening time. So tomorrow is economic dispatch, which is related. It's a kind of similar, and then we will do MATLAB as well as games for economic dispatch. Okay, so this is it. Thank you very much.